Myself Harshavardhana CN, Assistant Professor of Mathematics. In this session, we are going to learn indeterminate forms, solve the problems on indeterminate forms using L'Hospital's rule. Here, the learning objectives are definition of indeterminate forms, L'Hospital's rule, solve the indeterminate forms of the type 0 by 0, infinity by infinity type problems. The indeterminate forms. While evaluating certain limits, we come across expressions of the form 0 by 0, from infinity by infinity, 0 into infinity, infinity minus infinity, 0 power 0 and 1 power infinity, which do not represent any value. Such expressions are called indeterminate forms. We can evaluate such limits that lead to indeterminate forms by using L'Hospital's rule. Now we are going to study what is L'Hospital's rule. If f of x and g of x are two functions defined on some interval, satisfies Cauchy's theorem and such that, first condition, limit of f of x as x tends to a equals to 0 and limit of g of x as x tends to a equals to 0, and f dash of x and g dash of x exist and g dash of a not equals to 0, then limit of f of x divided by g of x as x tends to a equals to limit of f dash of x divided by g dash of x as x tends to a. This is our L'Hospital's rule. Note, the above rule can be extended. That is, if f dash of a equals to 0 and g dash of a equals to 0, then limit of f of x divided by g of x as x tends to a equals to limit of f dash of x divided by g dash of x as x tends to a, which is equals to limit of f double dash of x divided by g double dash of x as x tends to a. Note 2. We apply L'Hospital's rule only to evaluate the limits that in 0 by 0 or infinity by infinity form. Here we differentiate the numerator and denominator separately to write f dash of x and g dash of x and apply the limit to see whether it is a finite value. If it is still in 0 by 0 or infinity by infinity form, we continue to differentiate the numerator and denominator separately to write further f double dash of x divided by g double dash of x and apply the limit to see whether it is finite value. We can continue the above procedure till we get a definite value of the limit. We observe these properties in our problems. Problems on indeterminate form 0 by 0. First problem, evaluate limit of x minus sin x divided by x cube as x tends to 0. Here we put x tends to 0 means substitute the value of x equals to 0. Here x equals to 0 minus sin 0 divided by 0 cube, which is equal to 0 minus sin 0 is nothing but 0, 0 by 0, 0 by 0 form. Apply L'Hospital's rule. That means differentiate numerator and denominator with respect to x, because here x is the variable because x tends to 0 with respect to x. The differentiation of x is 1 and differentiation of sin x is cos x, and differentiation of x cube equals to 3x square. Suppose if we again put x tends to 0, 1 minus cos 0 divided by 0, 1 minus cos 0 divided by 0, which is equals to 1 minus 1 by 0, again 0 by 0 form. Again apply L'Hospital's rule, we get limit of x tends to 0, differentiation of 1 is 0, minus cos x is nothing but sin x divided by differentiation of 3x square is nothing but 6x, which is equals to 1 by 6, because limit of x tends to 0 sin x divided by x equals to 1. Therefore 1 into 1 by 6, which is equals to 1 by 6. The value is 1 by 6. Next, evaluate limit x tends to 0 tan x minus x divided by x square tan x as x tends to 0. Given limit of tan x minus x divided by x square tan x, which is definitely here tan apply x tends tan 0 minus 0 divided by 0 into tan 0. Tan 0 is 0, 0 minus 0 divided by 0 into tan 0. This value becomes 0 by 0 form. First we are going to adjust this, multiply and divided by x here. Also separate this limit of, see this limit of x tends to 0, x by tan x is nothing but 1. Therefore this value becomes limit of tan x minus x divided by x cube, which is equals to 0 by 0 form. Apply L'Hospital's rule, which is equals to limit of differentiation of tan x is nothing but secant square x minus differentiation of x is nothing but 1 divided by differentiation of x cube is 3x square. Again, after applying limit secant square 0 minus 1 divided by 3 into 0, 0. Secant square 0, 1, 1 minus 1 by 0, which is equals to 0 by 0. Again 0 by 0 form. Again apply L'Hospital's rule, differentiate the function, which becomes limit x tends to 0 to secant square x tan x divided by 6x. Therefore separate this limit, limit of x tends to 0, product of the limits. You can write limit of f of x into g of x implies limit of f of x into limit of g of x. Therefore limit of x tends to 0, secant square x by 3 into limit of tan x by x as x tends to 0. Here this value becomes 1. Therefore secant 0 is nothing but 1. Secant 0 equals to 1. Therefore 1 square 1 by 3 into this value is 1. The total, the limit value is 1 by 3. Next, evaluate limit of x power b minus b power x as x power x minus b power b. Solution: given limit of x power b minus b power x divided by x power x minus b power b as x tends to b. Suppose if you apply x tends to b, this becomes b power b minus b power b divided by b power b minus b power b. This becomes 0 by 0. Therefore this value is 0 by 0 form. Apply L'Hospital's rule. Here x is variable and b is constant. The differentiation of x power n is nothing but n into x power n minus 1, like that, b into x power b minus 1 minus the differentiation of b power x is nothing but b power x into log b. Here both x and x, power also variable, this x also variable. The differentiation of this is x power x into 1 plus log x minus the differentiation of b power b, which is nothing but constant, which is equals to 0. Therefore this is the differentiation, which is equals to apply limit b into b power b minus 1. Don't write this again. B into b power b minus 1 minus b power b log b divided by b power b into 1 plus log b. Here see this, b power b minus 1 into b equals to b power b minus b power b into log b divided by b power b into 1 plus log b. Take b power b is common factor numerator and cancel. We get 1 minus log b divided by 1 plus log b. This is the our limit value. Next, evaluate e power x minus e power minus x minus 2x divided by x square into sin x. This is given problem. In place of x to substitute 0, then e power 0 is nothing but 1 minus 0 divided by 0 into sin 0 0. This value 0 by 0. But before going to apply L'Hospital rule, here an adjustment is there. Multiply and divided by x. the in the denominator x square is there, multiply x square, x cube into x by sin x. But the limiting value of this is equals to 1. This value becomes limit of x tends to 0, e power x minus e power minus x minus 2x divided by x cube. Again apply limit e power x e power 0 1 minus e power minus 0 1 minus 0 by 0, again 0 by 0 form. Apply L'Hospital's rule. The differentiation of e power x is e power x minus e power minus x is minus of e power minus x, minus into minus plus e power minus x into minus 2 into x, 2 into differentiation of x is 1, therefore minus 2 divided by, for x cube, 3x square. Again apply L'Hospital's rule, which is equals to limit of x tends to 0, e power x minus e power minus x divided by 6x, which is nothing but, see, again put x tends to 0, e power 0 1, 1 minus 1 by 0, 0 1 minus 1 divided by 0, 0 by 0 form. Again apply L'Hospital's rule, limit of x tends to 0, differentiation of e power x is e power x, e power minus x is minus of e power minus x. Substitute this value, x tends to 0, e power 0 1 plus e power minus 0 also 1 divided by 6, 1 plus 1 2, 2 by 6 3, 1 by 3. This is the required answer. Evaluate limit of x minus log of 1 plus x divided by 1 minus cos x. Here as x tends to 0, put x equals to 0 here, that means x tends to 0, 0 minus log of 1 plus 0 means log 1 divided by 1 minus cos 0. The value of log 1 is 0, 0 minus 0, 0 divided by the value of cos 0 is 1. Therefore 1 minus 1, which is nothing but 0 by 0. This value is 0 by 0 form. Apply L'Hospital's rule. Therefore differentiate numerator, that means differentiation of x is 1 minus differentiation of log of 1 plus x is minus 1 divided by 1 plus x. Differentiation of 1 is 0 for minus cos x, which is nothing but sin x. Definitely again apply limit as x tends to 0, which becomes 1 minus 1 divided by 1 plus 0 divided by sin 0, which is nothing but 0 by 0, again 0 by 0 form. Again apply L'Hospital's rule, the differentiation of 1 is 0, the differentiation of minus 1 divided by 1 plus x is 1 divided by 1 plus x whole square, differentiation of sin x is cos x. Apply limit, x tends to 0 means this 1 divided by 1 plus 0 whole square divided by cos 0, which is equal to 1 by 1, which is nothing but 1. Here I given some exercises, solve according as above. You get the also given answers also. Next, note number 3, if f of x and g of x are two functions defined on some interval satisfies Cauchy theorem, and such that limit of x tends to a f of x equals to infinity and limit of g of x as x tends to a equals to infinity, and f dash of x and g dash of x are exist and g dash of a not equals to 0, then limit of f of x divided by g of x equals to limit of f dash of x divided by g dash of x as x tends to a. In most of the cases of the form infinity by infinity, care must be taken to change over the form 0 by 0 at the proper stage. Otherwise, the process will never end. Problems on indeterminate form infinity by infinity. Evaluate limit of x tends to 0 log of sin x divided by cot x. Here, log of sin x divided by cot x, put x equals to 0, log of sin 0 divided by cot 0. Log of sin 0 means log 0. Log 0 is nothing but minus infinity divided by cot 0 is infinity, which is nothing but infinity by infinity form. Apply L'Hospital's rule. Limit of x tends to 0, differentiate this cos x divided by sin x whole divided by minus cosecant square x. Simplify it and apply limit, we get this value becomes 0. Next, evaluate limit of x tends to 0 log of tan x to the base x. Here we know the one logarithmic property, log of m to the base n equals to log m to the base e divided by log n to the base e. Apply this formula. Therefore, log of tan x to the base x equals to log of tan x to the base e divided by log of x to the base e. Apply limit as x tends to 0. Log of tan x means log of tan 0. Tan 0 is nothing but 0. Log 0 minus infinity divided by log 0 minus infinity, infinity by infinity form. Apply L'Hospital's rule. The differentiation of log of tan x is 1 by tan x into secant square x, log x is 1 by x, which is again infinity by infinity form, which is equals to, simplify it, x by tan x into 1 by cosecant square x, because we know that limit of x tends to 0 tan x by x, this value equals to 1 divided by 1 by cos 0 is 1, therefore the total value is 1. The next problem is evaluate limit of x tends to 0 log of sin ax divided by log of sin bx. Definitely, if you put sin 0 is log of sin 0 is 0, log of 0 divided by log of 0, minus infinity by minus infinity, infinity by infinity form. Apply L'Hospital's rule. Limit of x tends to 0, a cos ax divided by sin ax divided by b cos bx divided by sin bx, which is equals to limit of x tends to 0, a cot ax divided by b cot bx, which is infinity by infinity. Here care must be taken, convert this into 0 by 0 form, otherwise the process will never end. Therefore, a by b, cot ax is nothing but 1 by tan ax and cot bx is reciprocal of that. Therefore, this value becomes like this. Again, apply L'Hospital's rule. Limit of x tends to 0, a into b secant square bx, b into a secant square ax, which is after applying limit ab into secant 0 1, ab equals to 1. This is the answer. Next, I given some exercises, solve as above. I referred the book Differential Calculus by Shanti Narayan, P.K. Mittal, textbook of BSc Mathematics by G.K. Rangnath, textbook of Mathematics BSc second semester by Professor G.B. Gururajachar, textbook of BSc Mathematics by B.V. Manjunath and Dr. C. Nandish Kumar. Thank you one and all.